Thank you, Ashrath. It's a pleasure to be here while Zohar setting it up. So the first time I came to Israel was actually for Aerospike 10 years ago, 2015. I mean, to come again, and I've been coming here almost once a year, maybe 7 or 8 times now. I stopped counting. It's really great to see what our team has been able to do and the customers. Okay. And I was talking to Asaf, who was the one who actually invited me to come here in 2015. He was part of a VC who had just invested in Aerospike. And I'm really glad I came. I got introduced to the Israeli culture of how discussions go. It was a fun experience, and I felt right at home, to be honest. And as I was talking to Asaf today, he was telling me, I was telling him that I love baseball, and he said I should explain to Israelis why I loved baseball, because it's very boring, but I'm not going to do that. All I can tell you is any game, I mean, in baseball, you hit a ball with a bat. That's about all I'm going to say. But the best hitters in the world hit 3 out of 10. That's too hard to think about. So Aerospike is easier, okay, is the way I think about it. So what I'm going to do is take you through some of the efficiencies. You know, this title was given to me by Ashrath. So I was thinking about what is it I'm going to talk about. And so I'm going to talk about efficiency over the years in Aerospike. Okay. Oh, I haven't pressed anything yet. Let's say I pressed. Okay. So I'm not going to, this talk is not going to be very technical. Because last time I spoke too technically and the feedback I got was like, that's too much. So what I'm going to do is I'm going to take you through the journey. And we've had 3 customers, right? Shift4, Rice, and BioCatch talk to you about the efficiencies that they have been able to achieve with Aerospike just this year, right? And this has been the story all along. And one of the foundations of Aerospike is the hybrid memory architecture. And the simplest way to think about it is we are now using the storage in SSDs instead of DRAM, and you saw that over and over again today in the talks by the various deployments. And what that means is the cost per bit for storing data in SSD is an order of magnitude lower than storing it in DRAM. Okay, so I'm not going to go into the details. So we do what is on the left here is what we do. What is on the right is what everybody else does, be it relational databases, other NoSQL databases, and so on. And we can go into the details separately if you have questions. Why is that important? Because you can put more SSDs per node. You can reduce server sprawl. And I will talk about, we can still maintain low latency. And these are some examples, okay? When you can, 450 servers to 60 Aerospike servers, 200. This is all numbers from 2015, okay, 10 years ago. And these numbers are still true, as you saw from from the talks that were presented today earlier. And then you have the similar thing, and we can basically went from 200 to 30. The difference is not just to, we put some names of like Cassandra and Couchbase, but forget about that. That is not the difference. The difference is between storing real-time data in DRAM versus storing real-time data on SSDs. And Aerospike has the algorithms to do that. And that's what's making the difference. Okay? That's number one. Great. I just said that you reduce 450 servers to 60 or whatever, 200 to 30. That all sounds well and good. But you still have to serve the same number of transactions per second on the entire cluster, which means if I reduce the number of nodes in the cluster by 10x or whatever, I need to do 10 times more transactions on every one of those nodes, which means we have to do a lot of work to make this work. And that's what this slide is. It's about parallelism. It's about making use of NUMA pinning, parallel access to disks, a distributed algorithm, figuring out how to read replicas instead of reading, if you have 3 replicas, I can read from any of those. So all of those techniques are used. Code is written in C, it's very efficient, and that is again, I won't go into the details of it, but that's what results in something like this. Again, this is numbers, I just went and found a bunch of benchmarks and numbers we have over the years. Again, don't pay attention to the competitors, because that changes from time to time. Just pay attention to the Aerospike numbers. The Aerospike numbers here, are right here, these red numbers here, and these numbers in the middle, right? The first one and the third one, okay? The first and the third, right? The first of the solid one and the striped one are differences between Aerospike 2 and Aerospike 3 or Aerospike 4. All I'm trying to point out is, it's not just about using hardware, it's also about improving code. And we've been doing that constantly over the years to keep our advantage. So we have improved both software and hardware. So this is about, in 2014, the top thing here is about 1.5 million TPS on an in-memory data set. And then we did this in 2018 on the right side with Intel. It's and we showed like literally 15 million. That's 10x growth. Okay? And that's kind of what makes all this continue to work 10 years after we started, okay? And it's all about the efficiencies that you're all enjoying. It's based on the work that we did over the years to keep our software up to speed, but also taking advantage of the new hardware innovations. So that's kind of the message. There is more here. Some hardware showed up and disappeared. One of them is PMEM. Intel's PMEM, we did a bunch of work on that. Okay, but again, in this, we were able to do work to make sure that if you keep your index in DRAM versus index in PMEM, the performance fall off wasn't much. And even though PMEM couldn't take off because there was no cloud adoption, we still did the work, and that did help our code to become better even in a DRAM case. There are some changes we did to the algorithms for that. So just think about this as a constant innovation and adaptation we were doing to the hardware and the environment. And it's not a product that's standing still. Okay? And again, there are lots of advantages. I won't spend too much time on PMEM because Intel discontinued it. So fast forward to 2022, and what we have here are Aerospike benchmarks, again done with partners. Okay, the first one on the left is a cloud benchmark done with AWS and Intel. And what we did was we showed a petabyte scale system with millions of transactions per second, both reads and writes, happening on 20 nodes. This can probably happen in 15 or fewer nodes right now, based on our innovations jointly done with AWS and also GCP for different instances, like i4 ICE and i4G. I'll get to that slide which Subbu talked about. But also on the right side, we still continue to work on bare metal. You can do it with 8 nodes on HP Enterprise. And again, you can do trillion objects, petabyte scale, millions of transactions per second. And all of this is a constant thing, And finally, this is the same slide that Subbu put up. Between i4Gs and i8Gs, there's a 3x improvement. And this is a purely hardware improvement. So our team, just so you know, has been working constantly over the last 10 years. Before the cloud, we worked with Intel, Micron, Samsung to test those SSDs. And we have this tool called the Aerospike Certification Tool, ACT, that those SSD providers used to run their firmwares on. And now, cloud providers can run it on their, like Nitro SSDs, Z3s, and so on, and various cloud providers. And we are able to continue to help move these workloads back and forth. It can run on bare metal, it can run on the cloud. We want to provide the same level of efficiencies no matter where you run on. And that's a commitment we make to you and also to ourselves. Okay, so that's on the basic hardware adaptation. I'll talk a little bit about the data distribution. I think you might have seen this data distribution. I won't go too much into it. The basic idea is we have a very robust partitioning function that can move, that can partition data within the cluster. It is providing a level of uniformity in terms of data balancing, but we are also able to deal with it when nodes go in and out. In fact, Evan showed a demo where he added a couple of nodes. All of these partition movements are happening right there when he does that. And this happens behind the scenes. So we spend a lot of time in self-management. This also creates efficiencies. The trick here is we are getting some natural efficiencies I showed you earlier in terms of adapting to hardware like SSDs and various networking technologies as well as processor technologies. Now, how much of it can you preserve when you add more database features? Okay, that's the purpose of this section. And what I'm showing here is, a basic database has various strong consistency data models, and we support all of these, okay? We support strict serializability. We support, of course, which means we support serializability. We also do linearizability, which is for single record operations, and serializability is for multi-record. So we support both of them now in different versions. Aerospike 4 introduced linearizable transactions, and Aerospike 8 has ACID transaction support, which is implicitly includes multi-record. Sequential consistency is still a strong consistency mechanism for reads. So you're able to read a little bit earlier than others. And here is a benchmark we did when we, with strong consistency. What you can see here is, if you look at the sequential consistency and availability mode is where you don't preserve consistency. Our reads and writes are pretty much identical in terms of their latency. It is 220 microseconds, and that required us to write code in such a way that we can preserve the performance we got from all the caching systems that we have and try to get as much of it possible when you run it as a real database. And the same thing we did again, with linearizable, we do have to pay a price for reads, as you would imagine, because I won't go into the details, but linearizable is a stricter form of read than sequential consistency. Both are consistent. You're not reading uncommitted data, but one of that, you can read a little bit older data in the sequential consistency case. In linearizable, you can't. It is by wall clock time. So you're serializing every update. We have a similar thing with strict serializability, and we do the same thing. So all the efficiencies that we have gotten by our work earlier, we are preserving it as we are building out these database features. We also have this other, and I think some of the presenters talked about XDR. It is a way to asynchronously move data around multiple geo-distributed clusters of Aerospike. I won't go into the details of it, but again, we basically, and this is actually going to be published. The previous numbers were published a couple of years ago for strong consistency. This is the XDR one. And the key thing here is how much impact that shipping data across clusters has on the transactions that are executing on it. And you can see in this table, right, if you look at the read, the outlier latency, it's barely anything. You are able to do the same number of TPS on the actual system for reads and writes, and then the writes will convert to XDR TPS because you're shipping every write to the other system. So you can actually maintain the same level of we are able to do it efficiently across clusters, but we are also able to not impact the transaction latencies. And this again is an efficiency thing because whatever efficiencies we're creating in the core system, we are preserving it as much as possible as you add more functionality, whether it is strong consistency, whether it is change data, capture and shipping data, and so on. In fact, I was talking to Tammy earlier today, and she was expressing, hey, how is that our XDR is so efficient? It is efficient because we work hard at it, and we have this basic focus that we have to put efficiency. It's basically good engineering, up and down the various parts of the product, which enables all this to work. And as Evan showed us, he's going to take this product, which does all this, and make it work on the cloud, so you don't have to deal with the management aspects of this. I'm just going to conclude by what we have done, how customers have, you already saw 3 customers present today. I'm just going to tell you over the years what people have done in terms of they have basically achieved goals which they didn't think were possible. I think Giddy mentioned it, and that's not just the people today, but it's been going on for almost like 14 years in various parts of the world. Okay, and I'm very happy we're bringing it here, but I think we need to ourselves expand it more. So please spread the word around. Here is an example. For example, this example is I believe PayPal. I didn't put any logos here. Because I think that's not as important. But the point is, they could actually grow 10x. This was, again, a 2015 thing. And since then, the 10x has been achieved many times over. But also, there was a 30x improvement in fraud transactions, completion rate. And that's really important, in terms of reducing the amount of things you miss. They were missing 1.5%, and they're now missing less than 0.05%. Of the fraud, and this is really important because when you're running fraud, we are doing it in real time. Okay, more and more, all the use cases I'm talking about here, where Aerospike, it usually runs at scale, requires predictable performance, and it has to, in this particular case, you got to finish the fraud score before the transaction completes in a couple of 100 milliseconds. And that's something, and the server reductions, you already seen that. It goes down to something from 360 to 20. And here is from a top, global brokerage firm. They went to the same kind of, thing. They were doing risk calculations overnight, and now they were able to do it every 2 minutes or 3 minutes, which means their margin loan business took off, and that made them extremely profitable. Again, they started a new business model, which they could not have done without Aerospike being able to help them compute their risk on all the portfolios every few minutes. And this, again, is something each of you can think about, what is possible if you have a system like Aerospike, and as you learn more about it, and then the ones who are new to it, this is what is, we are good at, and we can help you with. Here is the European central banks, and the main thing I want to focus here is, we're talking about efficiency. They needed to keep the cost per transaction. This is for real-time settlement of instant payments. So you can send a few euros to, anybody can send a few euros to anybody else. Then what happens is the cost is 0.0020 per payment. Because typically for these payments, you can't use any of the existing things. This is true in China, this is true in India, this is true in Europe, it's true in Israel, it's true in South America and Brazil. It's all like peer-to-peer, like the cash is going away, right? It's not happening. Basically you can just move money from your wherever the money is to wherever, whoever you're sending it, okay, using a phone number or whatever, okay. And that's really an important thing. So the cost per transaction payment has to be fractions of a cent. I have a minute. I believe this is my last slide. And this is, again, a large ad tech company. What you see is 80% reduction. And look at the number of records being processed. We saw that. This is even more records being processed per day. Than what we have seen. And that's, again, these are things which would be impossible to do. I would not say impossible. It would be really, really hard and super expensive to do with any other system. And one of the original, what I would call the goals of Aerospike was to make our technology help startups grow to Google scale without actually spending Google kind of money on it. And I believe we have succeeded to a large extent. More importantly, our customers and users have succeeded big time on this. There are many people, many companies in Israel who we worked with for a lot of time who all went IPO. So we're very proud of the fact that we've been associated with a lot of companies which have grown fast and have become very, very successful. And with your help in spreading the word, we hope we will join some of those companies in the future. So, these are the lessons learned. It's about, if you have more data available and you can make decisions faster in real time, it doesn't matter what the use case is, Aerospike can really, really help. That's kind of the thing. And it can be efficient, and that's why it's interesting. And thank you for listening, and thanks for attending today.